Good evening, students. Now today discuss about this unit 3 edge detection concept. What are the types of edges, threshold and zero crossing, and then gradient operators like that Roberts, Prewitt and Sobel operator. A residual analysis based on techniques, Canny edge detection and edge features and their application. There are two books are be there. One is Anil K. Jain book. Another one is a Gonzalez book. I will move to this that edge detection concept here. Uh, there is 9.4. So what this is like that edges. Normally edge means the top side corner or left side corner and then right side corner. What is the corner position? Inside of this is normal fundamental phenomena of image analysis is edge detection issues. So what are this is like that object characteristics of object boundaries, and there are for useful for segmentation, registration and identification of object in scene. So edge points can through what is thought of as a pixel location of a abrupt grace level change. For example, it is reasonable to define the edge point in binary images as a black pixels with at least one white nearest neighbor, that is pixel location m comma n, such that u of m comma n equal to 0 and g of m comma n equal to 1, where you will like that there will be equation of the g of m comma n delta equal to u of m comma n, addition of this two convolution addition of u of m plus or minus 1 comma n or operator u of m comma n convolution operator plus u of m comma n plus or minus 1. So in this edges normally it say this a gradient of f of x comma y to be reflection of this angle of 0 theta degree, and this radius r will come to analyzation from the edges will be performing here that location. So in this r direction it will come to like that plus or circle should be denotes the logical equation or operations. The continuous of this image can be gradient among this f along with r in the direction theta. Dou f divided by dou r equal to dou f divided by dou x into dou x divided by dou r plus dou f with respect to y divided by dou y into dou y divided by dou r. F of x cos theta plus fy sin theta. Maximum level you will come to analyzation from dou f divided by dou r of maximum equal to square root of f square x plus fy square, where theta g is the direction of the edges. Based on this concept, two types of edge directions like that gradient operators and the campus operators. In these digital images, these operators also called as mask, M-A-S-K-S, mask, whereas represent from this finite difference approximation of either the orthogonal gradients f of x comma f of y, or the directional gradient dou f divided by dou r. Let h denote a p by p mask and define for an arbitrary image u the inner product at location m comma n as a correlation. We will come to this as gradient operator. So you know what is this base model of this is gradient operator and campus operator. How to be what is mean by this mask? Everything we know from this previous concept. Now we move to gradient operator. The gradient operators like that's a pair of mask h1 and h2. This measure will come to say here the type of two type of edges will be like that here the type of information of a gradient pair of mask h1 and h2. We will say the type of the information defining representation of this below equation g of m comma n and theta g of m comma n. So in this image analysis, you will say this edge detection via gradient operator. u of m comma n with respect to h1 and h2, there are two type of pair of edges here, g1 of m comma n and g2 of m comma 2. What is the analyzation from both g and theta g, and the magnitude of g of m comma n is the direction which the edge map is there, will come to along with the threshold. Threshold to be fixing this value either 0 or 1. The level will come to fixation of threshold. So in this calculation to performing here from gradient level, gradient operator, the gradient operator commonly says is the Prewitt, Sobel and isotropic operator, compute horizontal and a vertical difference of local sum. This reduces this effect of this noise in this data. Note this operators were desirable of property of yielding zeros for uniform region. So here we say this is declared from edge location. Pixel location is m comma n, and edge location if f g of m comma n exceeds some of the threshold t. The location of edge point will be constitute of the edge map epsilon of m comma n, which is to be defined as epsilon of m comma n equal to 1 or 0. 1 means given that m comma n belongs to ig, otherwise 0. ig means delta or equal to m comma n given that g of m comma n greater than threshold value. So here we like this, the boundary will come to analyzation from that is histogram. So some common gradient operator boxed elements indicates the location of the origin. So here this is h1 and h2. The Roberts will come to say this is 0 1 or 1 0, minus 1 0 or 0 minus 1. The smooth pivot will come to that what is the transformation about this h1 and h2 value. The Sobel operator will come to minus 1 minus 2 1 minus 1 0 0 0 1 2 1. Isotropic will come to say the type of rational numbers, minus 1 minus square root of 2 minus 1 0 0 0 1 square root of 2 1. So the like that is a Sobel operator, Krisk operator, like that is a stochastic 5 into 5 Laplacian. So edge detection examples in each cases gradient images left, edge maps right. So in this each equations we come to say the largest gradients are declared as the edges. The gradients and the edge maps using the Sobel operator on two different images. So now we will move to campus operator. Campus operators will come to imposing from the type of a measurement like that direction. It's not going for edges. It will belong to the campus with north, south, east and west. It depends upon this angle 0 degree, 45 degree and 90 degree and 120 degree and 180 degree, like that vice versa 0 to 360 degree. So in this campus operator like that will come to say north, northwest, west, southwest, south, southeast, east, northeast. Like that is the eight direction to come to apply with the campus operator. U of m comma n and then gk of m comma n, gradient of g of m comma n, and finally h map depends upon the threshold value. In this gradient operator depends upon the directions, and then like you can say this the type of location. So in this the type of example will come to explain about this figures. Krisk operator, what is the main role of this gradient of the campus operator. In this example, how to say this the type of campus gradient to north. Each clockwise circular shifted of element about this center rotates gradient direction by 45 degree. Laplacian operator and zero crossing. The foregoing methods of estimated the gradient work best when the gray level transition is quite abrupt, like a step function. Like that, you come to say another along with the type of delta square f equal to dou square f plus divided by dou x square plus dou square f divided by dou y square. So in this concept, we will say the different type of amplitude function of f of x. Here we say this df divided by dx, the differential equation. Again, this derivative, first order derivative, second order derivative, the square d square f divided by dx square. So double edges will come to crossing over to zero crossing method. This is a normal edge will come to belong with the threshold value, and the double crossing is a second order derivation. So first and the second order derivative for edge detection. So this is the first order. The second order will come to say the first edge detection via zero crossing method. In this Laplacian of Gaussian, name is called log LOG, and Gaussian of difference mean GOD, God. We will say this the type of information like that. Here we say the discrete Laplacian operators, like we come to along with the zero crossing, second order derivative along with the or the direction between this data. So many gradients are there. Here we say this is a stochastic gradient. It is foregoing gradient mask perform poorly in this presence of noise. Averaging low pass filtering, like that, and we applying with the noise will come to this control manner. So this is a edge model with the transition from region from one pixel via y. This is a stochastic gradient from h1 for edge extractions of this value. Like that, you will come to say that the simplification about this, the type of SNR, signal noise ratio equal to 1, signal noise ratio equal to 9. Depends upon the sliding window 3 by 3, 5 by 5, and then 7 by 7. So in this performance, it depends upon this direction of this edge location P. Calculate this horizontal gradient for instant as well. We come to a representation from the type of value. Performance of edge directions operator, like that will come to application from each and every measurements based on this edge direction noise. So normally the error rate of edge direction PE equal to N1 divided by N2, N0. And the error rate will come to the application about the Sobel operator. Use the noisy images with the SNR approximately 10 decibel is 24%, whereas it is only 2% of the stochastic operation. So like that, we will come to say analyzation from the type of reduction of operator depends upon this quantity P. This is the example of a detection of noisy images. Upper two things are Sobel, lower two things are stochastic. So D is the distance between the pixels to be declared from the edge nearest from ideal edges pixels. Alpha is the calibration constant, and N1 and ND is the number of ideal and detecting of edge pixel respectively. Line and spot edge detections. Say here this is the type of extended edges. Table 9.0 you will come to say this campus gradient of line detection. So this is the line detection operator. Like that, the gradient for noiseless images, gradient for noisy image. Noisy image will come to say the salt and pepper noise will be appearing from this some type of gradient noise will be there. So in this example, we come to the comparison of the edge detection from each and every cases of 1, 2, 3, 4. The operators will come to smoothed gradient, Sobel, isotropic, and a semi-casual model based on 5 by 5 stochastic. Largest 5% of gradient magnitude were declared edges. So this is a line detection operator based on this east west and the northeast and the southwest and north south and then northwest and the southeast. In this boundary extraction, come to analyzation from the different type of formula. It will come to analyzation from connectivity of this, the type of pixel A, and then it's the center pixel, and then it will be connected from 4 connected method, and then 8 connected method, and then connectivity paradox. And the B and C's are connected. So why this 8 connectivity? The counter following come to this based on this edge linking and heuristic graph search. So this is the heuristic search algorithm, dynamic programming. This also must will come to analyzation from the different type of optimal boundary extraction. Op transform is another type of transformation technique to be applicable from the edge detection model. Boundary representation, that's based on the chain course method. This is a type of algorithm for counter bounding, boundary pixel orientation, and then it will come to the counter and the counter curve encode model. So fitting line segmented, B is splines representation. So here we say another type of edges will come to say different type of step and roof and horizontal and vertical, and a combine of so many type of edges will be there. The normally common from transformation along with translation, scaling, rotation. So uniform periodic B splines will come to analyzation from control points. So the boundary representation be along with the type of periodic case, non-periodic case, normalization from the type of informations, control points. So these are the property of Fourier descriptive. The help of this edge detection method, boundary matching. So much more like that is a feature of this. So many edge detection features we come to analyzation from the type of model directions. So here we say there's a type of boundaries. The type of transformation techniques also will come to analyzation from this diagram. Region representations is also the help of the type of quadrant, projection, movement representation. This is advanced topic about this the particular edge detection method. So many type of algorithms will come to analyzation from the type of edge detection techniques. So this is another type of morphological techniques will come to support it from the type of transformations. Thinning and synthetic representation, shape features. This is another important thing about this feature of edge detection. Normally shape is also important measurement will come to analyzation from the shape representation, regenerative features and measured features, boundary, region, moment and structural and synthetic. Geometry will be like that perimeter, area, maximum, minimum, radii and eccentricity and corner and roundness, bending energy, folds, Euler number, symmetry, center of mass, orientation, boundary, rectangle, base fit ellipse, eccentricity. So moment based features. This is another type of observation of these structural patterns like that texture. So image transform, edge intensity, histogram and random texture models like that we come to approaches from the type of different type of models. Scene matching and detection. So another type of image segmentation role. So these are the things we'll come to study about this detection things. Now another book will be say some type of information from edge detection. This concept will come to more appropriately to come to nearest link with the edge detection models. So what is this major edge detection method? Both will come to say the color edge detections. Normally that paper will come to including from edges here. In this concept will come to say the type of image segmentation role. In this model will come to say analyzation from the different type of edge detections. So normally edges like that, this all the type of edges will come to study about this in this book. Simply will come to horizontal, vertical, step and roof. That is, this lines will come to isolated points. What is the like of roof edges? Ramp and step all have been known. Will be combined of this step and roof. It will come to analyzation from the type of roof edges. There is a background study already study about this edges. So some types of edges will come to this point or line method. That book already that derivation will be there, same concepts. But here it will be say the different type of edges here study. a ramp and step, ramp edges on the left, step edges on the right side. Roof edges are come to this refer to involving both ramp and a step. See, like that here this step for intensity value, for here ramp edges and step edges. So here this says some type of line will come to isolated point, you will come to join, whether this is flat segmentation. Sometimes that is the equation come to representation from first order derivation, second order derivative. Second order derivation come to zero crossing level, to moving to 0 to negative value to positive value. Like that will come to touch over to zero crossing method. This is normally that 3x3 spatial filter. This is like that mask. Here they say W sort as kernel coefficient. So here this is a detection of isolated points. How does this identification about this? The type of edges and line direction. Here they say the type of mask of Laplacian kernel to be supporting from the type of different type of edge directions. So here this is another type of example of a Laplacian image to identify this magnified of section, to identify this Laplacian models. So this is horizontal, this is the vertical, and both will say it's a plus 45 degree, minus 45 degree. Edge model, you like that the image as a major role for images based on this abrupt local changes in intensity. So here this image wire bound templates. From left to right models to be ideal of the representation of the step. Here we say that the type of information, we say that three type of images models, we say the right side of this model ideal representation and step and ramp. Step and ramp. Step, this is a ramp, another is roof. So both will come to raising the information and downwards this ramping this information. So automatically it says roof of this edges. So in this say here roof edges, the third type of edges called roof edges. So normally this chapter will come to study from edge detection model. So normally edge will come to analyzation from the different type of inline and outline boundary. We will come to say this ramp edges, how to be analyzation from horizontal intensity profile, first derivative, second order derivative, like that is a zero crossing. So what is the behavior of this type of information? We will come to performing from edge detection, image smoothing for noise reduction. We will come to analyzation from the type of information among that particular role. And the first column will come to say the type of information of value of ranges and the basic edge direction properties. So already we studied about this image gradient and properties. How to computing this level of gradient origin and the gradient vector and then gradient edge directions. Gradient operator, already studied about this two type of information like that Sobel and Roberts. There is a Robert operator based on this image diagonal reference. 1D kernel. Here the 3x3 impacting like that Robert is a 2x2, Prewitt is a 3x3, Sobel is a 3x3. But here you say this is a difference about this type of information of mask level. -1 0 0 1 0 -1 1 0. Here Roberts will come to say -1 -1 -1 0 0 0 1 1 1, and reverse order will say a column. Here this column to row -1 -1 -1 0 0 0 and then 1 1 1. Prewitt will say this column you will get a -1 -2 -1 0 0 0 1 to 1. Here -1 -2 1 -1 0 0 0 1 to 1. So normally you say this is a type of problem will come to centralized location of this providing from image smoothing. these kernels will come to Sobel operator. So image smoothing will come to Sobel kernels to better noise suppression or characteristics. Normally, the information about this, the type of operators or gradient operators depends upon this value or location will come to change over from which campus kernel. Already we studied about this previous book. So this is an image of this intensity levels of scale, gradient angle of image computed to combine the gradient with the thresholding. So normally we come to improving the quality of this gradient with the thresholding value. So more advanced techniques for edge detections. So more filtered edge detector to be using from LOG log Laplacian of Gaussian and difference of DOG difference of Gaussian. Especially with the help of this the type of log kernel. The information to be edge detection method to force with the type of edge detection. Already shown the difference of Gaussian DOG. So this method will come to zero crossing found here with the ratio is there from log and log. Canny edge detection. What is the major role for Canny edge detection? In this algorithm to perform this Canny edge detection in Canny year 1986 discussed in this section superior in general to this edge detection. What is the main basic objective? Low error rate, edge points should be well localized, single edge point response. So in these cases, the essence of this Canny work was in expressing the preceding three criteria mathematically. We will come to optimal step edge detector, the first derivative of the Gaussian. We will come to along with the type of information d divided by dx e power minus x square divided by 2 alpha square equal to minus x divided by sigma square. We will be equivalent from the type of information, the type of smooth edges to be analyzed from the different type of gradient image. So normally the edge normal is the edge normal defined. What is the upper and the lower? Particularly say edge normal gradient will come to the type of vector. We will come to analyzation from the type of circle format. How to this edges, how to this vertical edges, how to the horizontal edges to be performing here, and also everything to be come to analyzation depends upon this 360-degree rotation. So we violated from suppression of this non-maximum suppression. We come to identify this directions and k denoted this norm of delta fs at x comma y. In this repeated of this value of x and y, we will be say the type of thresholding of this value, both false positive and value will come to a suppression about this the type of thresholding value. So the two additional images of the thresholding like that will come to implement of a threshold from horizontal threshold from low threshold and high threshold th and tl. So along with the type of this information, longer edges are formed using the following procedures. Locate will come to normalize from non-zero elements. It will come to approaches from summarizing from Canny edge detection algorithm. Consists of the following step: smooth the input image with the Gaussian filter, compute the gradient magnitude and angle images, apply non-maximum suppression to the gradient magnitude image. Use double thresholding and connectivity analysis to detect and link edges. So normally you will come to force with the type of images like that. This is a original image. A more filtered algorithm will come to approaches from the image obtained using to define from the type of the edges. So this is the image obtained using Canny algorithm. This is a significant improve this Canny image compared to this other two. So why to say the type of information to along with that the type of more algorithm image obtained from Canny. Before you come to this original image, this is a threshold image, and then this is the image more habitat image. This is this Canny image. So Canny will come to produce from the good better research. Linking edge points will come to say another type of features of this information to in this edge directions concept. So normally you say this feature edge features and their application. So why to say the type of application regarding from edge come to biometric and systems, and then face detection systems, and then all the type of typical application to be detection area, all the area will come to application from edge detection role. So this is just the best example to come to supply from the type of edge detection. So normally the edge detection role from rear vehicle number plate systems, image of the rear of the vehicle, gradient of magnitude of image, vertical connected from the edge fixtures, composite analysis from the different type of background image. So some type of algorithm of transform to the help of this type of edge detection techniques. So another type of sinusoidal curves will come to say the type of equation come to xj cos theta plus y j sin theta equal to p. You say the type of sinusoidal application of the plane informations. So basic properties of transformation. Here come to analysis from the type of parameter of corner of in this image. QRS point labels. So how to this returning for edge linking and transformation approaches. The half transform of edge linking to be separable from any type of the type of which one satellite image, radar images, everything will come to analysis from the type of role. Normally we say this thresholding is this vital role from all the image segmentation, especially that is image will come to formally the intensity value, either to fixing this value the corresponding depends upon the problem, so either to separable from background or white ground, you say that type of amplitude functions. So fixing, for example, 125 is fixing the threshold mean 125 below is black 0, above means you come to say this is 1. So in this say the different type of 2 or 3 threshold, multiple threshold model to be helped to be designed with a background or a white ground, and then in between middle of the say in between say this as grayscale, gray level. The type will come to 3 different type of 2 type of thresholding level. So the role of noise in image thresholding will come to analysis from the type of information of this image threshold. So global thresholding normally will come to analysis from the type of iterative algorithm. Select the initial estimation of the global threshold t. Segment the image using t in the equation 10 to 10.46. This will be produced a two group of pixel G1 consists of this intensity value greater than t, and then G2 is the consist of the pixels of less than or equal to t. Compute the average mean intensity value M1 and M2 for the pixels in G1 and G2 respectively. Compute a new threshold value midway between this M1 and M2. T equal to 1 divided by 2, M1 plus M2. Repeat the step 2 through the 4 until the difference between this value of T in successive iterations. Normally, you will come to linking whether this noisy fingerprints will come to along with the type of histograms. The fingerprint is come to the thresholding in image border added from clarity. Global threshold. One of the examples of this optimum global thresholding using Wurtzow method. This is another case of multi-thresholding approaches for Wurtzow method. In this case, you will come to so many type of mean intensity value. Like that, is that equations are probably to be supported from multi-threshold thresholding approaches. This is our algorithm to be performing from so many type of edge detections applications. So using smoothing and to improve from global thresholding issues. So these are this model from to analyzation from this noisy images to improving from that algorithm to be supported from global thresholding. So all the type of used to sell the multiple threshold will come to supported from so many arbitrary so many applications of this arbitrary of this level. The multiple global thresholding to be implement of all the type of iceberg image on iceberg and all the type of satellite images. So this is the variable thresholding based on the moving average. And script, another model come to say that type of supported from text image corrupted in the spot shading. That is the result of threshold for Wurzel method. So simply will be all the darkness point will be removed to identify this all the unscripted model. So these are the main thing. You come to study over to the type of the applications. Already study about this digits and then method in our exercise, practical exercise. For example, in your edge detection role, I have done for this program here from OpenCV. In this case, OpenCV, I have done is move to sources, samples, and then taken from Python, and then selected from edge detection method. Edge method. The program using from edges. Simply a file pressing here. There are two type of thresholding point here, threshold 1 and threshold 2. See here the type of edges like that is method will come to say the outer line, and then removing from threshold from to improve from threshold value. What will be happen here? Say the type of threshold to be become nearby 0 will come to this approaching from here, and then the vital role of threshold 1 so to be improved from inner threshold line, correct? So here both value come under this understanding about this 0. See here all the edges will come to produce, correct? Some type of threshold I'll be improved from this quality of level. See highlighted from removing from that outer line. So here say improving from this quality of this level of edges, and finally I will got this only outer line of this edges, clear? Outline, it's not internal part of this our hand, correct? So internal edges like that will be improved here from threshold, and then outer line edges will come to force with nearby this level will automatically internal will come to be produced from this level, correct? So this is this example from inner line edges, outer line edges of this threshold. All of it clear? What can I say from the type of edge detection rule? Clear? The same thing will come to in this offline program, offline thing will come to I running from this normal Python program. I will show this example here, edge detection problem. See the type of processing here, morphological. Second method is the edge detection method. Correct. Edges. See edge detection method. To compile under this the type of running example, all the type of edge detections based on this Canny, Sobel, Prewitt, Laplacian, and Gaussian of noise, second order, first order derivative, and then what is the type of dog, Laplacian of Gaussian, difference of Gaussian, and the type of all the type of information. See here, Sachin Tendulkar, the original image. This is the converted to grayscale level image, Canny edge detection, Sobel edge detection, and a Prewitt edge detection, Laplacian edge detection, and then Laplacian of Gaussian. Combined with the Gaussian edges, we come to say this here. Here this is the log edges. Here this is a dog. Difference of Gaussian edges. So normally you will be say Canny edge detection is the best method to providing from your result. Okay, I think finishing from third unit. Thank you for this listening from our that third unit. I will be recapping from all the third unit topic, edge detection. Already study of type of edges, horizontal edges, vertical edges, and ramp edges, and then step edges, and then roof edges. And what is meant by thresholding? Global thresholding, how to be performing thresholding? What is the first order, second order, zero crossing level, and then gradient operator like that, Roberts, Prewitt, and the Sobel operator. Residual analysis based technique based on this off transformation, and a Canny edge detection already we study about here this feature, and then edge features like the contour, border, and edge linking points, and the different type of applications already studied. Okay, thank you for the students.